clear the output for you. So this is a really simple version of printing out the board, and we can keep it for now. But I'm going to copy over and paste the solution workbook, which is essentially the same idea. It just has a little sleeker bit of formatting here. So if I run this, I get back kind of a more spacious board to look at. It's up to you what you want to do here. Lots of different options. Main idea was to be able to index board and then print it out. Step 2 was to write a function that can take in a player input and assign their marker as X or O. Again, lots of different ways we could do this, but something we definitely wanted to do was to use a while loop. That way we can continually ask until you get a correct answer. So I'm going to set marker as an empty string, basically anything that's not X or O. And I could do this two ways. I could say while marker is not equal to X and marker is not equal to O. So I could do it this way and then say marker is equal to input player 1, choose X or O. And then what I can do is uppercase this in case they accidentally put in a lowercase x or a lowercase o. And finally, I'll return some sort of tuple assignment. So I'll say if marker is equal to X, return X comma O. And so the format here, I can write myself a little note. And in fact, this would be a good case for a docstring, is to say that the output is in the form of a tuple with the player 1 marker, a little cleaner. It depends to you what is more readable. But looking across the top, the flip is equal to 0, then we return, let's say, player 1 as they're going first, else we return the string player 2 for going first. And there's lots and lots of different ways you could have done this, but this is kind of a simple way with the random.int, or random integer function. So let's run that. Okay, step number 6 was to write a function that returns a boolean indicating whether a space on the board is freely available. So it's going to take in that board, which is a list, and then take in a position, and it wants to check if it's freely available. And for our case, freely available means that that position is currently an empty string. So to do that, what I'm going to say is get the board at that position, and then see if it equals a blank string. And since that's already itself going to be a boolean, we're just going to return that. Then step 7 is to write a function that checks if the board is full and returns a boolean at that position, and then see if it equals a blank string. And since that's already itself going to be a boolean, we're just going to return that. Then step 7 is to write a function that checks if the board is full and returns a boolean value. True if full, false otherwise. So to do this, we're going to run a for loop that goes for I in range 1 through 10, because there's 9 spaces on the board starting from 1 at that position, and then see if it equals a blank string. And since that's already itself going to be a boolean, we're just going to return that. Then step 7 is to write a function that checks if the board is full and returns a boolean value. True if full, false otherwise. So to do this, we're going to run a for loop that goes for I in range 1 through 10, because there's 9 spaces on the board starting from 1 and then up to but not including 10. We're going to say if, and then we can call our space check function that we just defined up here. So if space check, using that board at position I, so that's all the positions possible on the board, if space check returns true, then I'm going to, and this is kind of a double negative here, but we're going to return false. So what this means is if I have a space, that means my board is not full, so I will return false. Otherwise, if I go throughout this entire for loop and I don't return false, then I will return true because my board is full. So board is full if we return true. Okay, so that's the full board check function. Step 8 is to write a function that asks, otherwise, if I go throughout this entire for loop and I don't return false, then I will return true because my board is full. So board is full if we return true. Okay, so that's the full board check function. Step 8 is to write a function that asks for a player's next position as a number 1 through 9, and then uses the function from step 6 to check if it's in a free position. If it is, we return the position for later use. So we'll do the following. We'll say position, and we'll have it be a placeholder at 0 because we know that at index 0, nothing's going on there. And we can say while position is not in the list of possible positions, so that can be 1, 2, 3, 4, 5, 6, 7, 8, 9. And we could have used range along with a list to make that happen. Or that space is not free, so we can say or not space check at board position. We'll ask the player for a position. We'll say the position is equal to the integer of the input. Choose a position, 1 through 9. And then finally, after all this, we're going to return that position. So all we're doing here is the following. We'll say position starts off at 0, and while the position, if the player for some reason is inputting the wrong number, or if they're inputting a letter, that's going to be this check to see if it's an actual number that's on the board, or it's going to check, hey, is that space still available? And then we're going to return the position once these have been satisfied. So we should only be calling player choice later on after we check if the board's been full. So the board being full is going to be a nice way to check if there's a tie, because if the board is full and nobody's won yet, then we know there's a tie. And we know there's a tie. Okay, step 9 is to write a function that asks the player if they want to play again and returns a Boolean true if they do want to play again. So lots of different ways we can do this. One way is to just say input play again, question mark, enter yes or no, and we're going to say that's going to be their response. Let's just have that be their choice. And we'll say return choice equal to yes. So here we're assuming the person is actually putting in the correct values. If we get choice not equal to yes, basically they have to write yes perfectly, otherwise we'll assume they don't want to play again. All right, and that's our replay function. Now step 10 is the hardest part, where we actually have to code out all the logic. putting in the correct values. If we get choice not equal to yes, basically they have to write yes perfectly, otherwise we'll assume they don't want to play again. All right, and that's our replay function. Now step 10 is the hardest part, where we actually have to code out all the logic. So this is going to be our largest block of code, so we'll finish this off in the next lecture. We'll see you there.